All right. Very excited to be here. I'm very excited to talk to you about becoming a Go contributor and whether or not you're interested in contributing to Go. Hopefully you can come out of this talk with some useful tips that you can take back to your day job. So what does contributing mean? There can be at times a real no true Scotsman vibe to contributing, where there's always some higher threshold you have to pass to be a real contributor. And every time this comes up, or I get this feeling, I'm reminded of this movie called The Truman Show, where the gist of the movie is Truman is on a set his entire life, and he's surrounded by actors who are trying to keep him on the set. And so he at one point says, "I'd like to be an explorer." And the teacher points to the map and says, "Well, there's nothing left to explore. Like, it's all been explored already." Just because the map exists doesn't mean that there aren't things you can explore at the bottom of the ocean or in space. And just because the standard library isn't changing that much doesn't mean that there aren't tons of ways for you to contribute. Ashley McNamara talked about this in her talk at GopherCon last year. Highly recommend you take a look. Just search for Ashley McNamara GopherCon 2017 and you should find it. It's a great talk. So one of the easiest ways to contribute is by using Go. Hopefully you are using Go, you're here. But maybe at the margin you could be using Go more than you are. You could write a new service in Go, or you could write that command line client in Go, or you could use Go in ways that you are uncomfortable with or that Go is not typically used, and then report back from your experience of using Go in an unfamiliar way to the broader community and learn from using Go. So when you're using Go, notice things that are confusing. This is probably the technique that's gotten me further in my career than anything else, is just noticing when things don't match up with your expectation or they're confusing, and then digging in. So here's an example. I was parsing every person that had ever committed to the Go project. We were parsing their email addresses using the mail package. And this email address returned an error. And the actual problem with this is the parentheses are broken, or the parentheses break the parser. But the error message returned by the mail library used to say no angle adder. And that's really confusing because there is an angle adder. You can see it right there. That's the bracket thing. That's not clear. So that's really confusing, right? And you might be thinking to yourself, well, this is a pretty small fix. This is a corner case. It wouldn't really help that much, or I shouldn't spend the time in actually fixing this, or it'd be embarrassing to submit a patch for this because it's so small. But the numbers that the Go community has now are really significant. Russ Cox estimates there are a little more than 1 million Go developers nowadays. So if 1% of them use the net mail package, that's 11,000 people. That's about 5 times the size of this room. If 1% of them hit that edge case, that's 110 people. That's probably about 10 rows of the audience. That's just this one edge case, right? So even though it looks like a small fix and it looks like a small issue, fixing it can actually have a really big impact on the future and an impact on people's experience of using Go. Contribute error reports. So when you use a program and it's not working correctly, you want to tell someone about it, right? And contributing a good error report is a skill. If you grew up in the US, probably around 7th grade, you got introduced to the hamburger essay, which was a format for writing essays for taking the SAT or other standardized tests. This is the hamburger essay equivalent for writing error reports. I highly recommend you follow this approach. It's really, really helpful and really useful for producing a useful error report. This is the template that I follow for every single issue that I file against the Go project or any other project. So what were you trying to do? Let's say I was trying to write data to a file. What did you expect to see? I expected to see the data in the file that I wrote. What did you see? Well, the data in the file was mangled or incomplete or some other problem. And finally, how can I reproduce it, right? How can I, as the maintainer or the library owner? Last step is super, super, super important. But yeah, this is really helpful because a good error report can vastly increase the chances that your issue actually gets fixed. If you go from it doesn't work to actually, hi, I was trying to do this and this is why it broke, you've probably 10x the chance of actually getting your issue fixed. Reduce test cases. So that's the last step on the previous slide, is taking a large program that is behaving in some bad way and then compressing it down to the smallest possible unit that reproduces the error, the problem that you were seeing. Again, a really, really, really valuable skill and something that you can transfer to your day job. Whether you're reporting stuff to Go or whether you're reporting stuff to any library, it's super, super helpful in getting stuff fixed if you can present a reduced test case that shows how to reproduce the issue. There are 3 properties of a good reduced test case. It reproduces 100% of the time. So if it's a flaky program, you want to find a way to trigger the bad input 100% of the time, or run the program in a loop until you can get it to reproduce. And that's super important because you don't know that you've fixed it unless you can actually reproduce it 100% of the time. So you reproduce it, you apply the fix, and the problem goes away. That way it's really, really clear that you've actually fixed the problem and not just kind of pulled the lever on a slot machine. Small, fast program. So fast is super important also. It should be fast to reproduce the problem. Because the faster you can reproduce the error, the more experiments you can run in a set period of time. If the error takes 5 minutes to reproduce, for example, that means you can only run 12 experiments per hour, right? And that's if you're super on it and you're not like checking Twitter in between, test cases. On a common-ish OS, yeah. So not a lot of people are running Plan 9, for example. So if you can reproduce it on a Linux machine or a Mac machine, that can be helpful for getting your issue fixed. Or explain how to reproduce those issues on those systems. So here's an example. This is from Daniel Marti. He reported an issue in the compiler, and here is a 7-line program that reproduces the error, right? It is super easy if you're working on the compiler to shove this in a test case and verify that it's fixed and not. And the chances of Daniel getting this issue fixed are very, very high. The chances if he submitted a 200-line program are probably still high since it's the compiler, but less high. So yeah, so super, super useful skill, whether you're contributing to Go or whether you're not. And this is a contribution, to be clear. This is super, super valuable because the Go team is running a subset of Go programs that exist in the world. So they don't know and they might not be running the programs that you're running and seeing the errors that you're seeing. Reduced test cases can suggest contributions. So maybe on that last slide, the mere process of narrowing down and isolating this issue has suggested where the actual problem is, right? So if you go through this process, it's a great way to actually get started making a patch. So if you submit this reduced test case, you might say, well, it looks like the problem is here because I've narrowed this down to a 10-line program. And I might take a gander at fixing this. And then you can go forward and do that. And this is a really good way to get started making contributions, is by practicing reducing this down to a manageable size. Contribute examples. So examples are the code snippets that sit in the documentation alongside the documentation. They're really helpful. And the reason they're really helpful is because people don't read anything on the internet. People scan for the information they're looking for. It's not like people don't read your documentation like it's a bonfire of the vanities, right? Like they're scanning through for the information that they want, that they need to find. And so examples have super, super high like information density, right? Like people scanning through the docs will focus on an example because it looks like it's going to have the solution to your problem, right? If they're trying to figure out how to use an API. So super, super, super helpful. Here's an example of an example. This is how to use the time.sleep package. It also demonstrates how to express 100 milliseconds in code. And it gets the point across in a way where a paragraph might not. So again, these are super useful. But they're not implemented everywhere yet. So here's the thumped package, which you're probably familiar with if you've used Go at all, or in Hello World program, you probably use the thumped package. It has a really big API. There are a lot of different ways you can use the thumped package to do stuff. And it has one example. There's one example in this entire package. And I'm kind of disappointed because I gave this talk in October of last year. And I was updating my slides last night, and I was like, I wonder if anyone's added examples to the package, but no. So you could be that person. You could make me update my slides. Please make me update my slides. Contribute documentation. Again, super helpful. It's really easy for documentation to get by without existing or get out of date. If you wrote something and it's not as popular or people aren't using it as much as you hoped, there's a good chance that it's because of the documentation or the lack of documentation or the incorrectness of the documentation. So I wanted to give one example. This is the script package. So I was using this for work. The script package will take a password like hunter2 and turn it into a 32-byte string in such a way that it's really expensive to guess, and it's really expensive to, if you have the key, to work backwards and try to figure out what the password was. So it's valuable for things like hashing passwords on websites. But anyway, so it has one function in this package called the key function. And if you read through the docs, it says, the recommended parameters for interactive logins as of 2009 are n equals 16,000, r equals 8, p equals 1, right? These are parameters that you have to pass to the function. Basically, like how hard should script work to derive a key? Well, the problem is it's as of 2009, right? So it's like that's not good. Computers have gotten faster since 2009. And this is sensitive, so if I don't get this right, I might be exposing my client to a security issue, so I want to make sure that I'm actually setting this to a valid value, a good value. So the first step is always, when you encounter any problem, should be to file a GitHub issue, even if you know what the fix is going to be, because there are other people that are going to run into the same problem that you ran into. They're using older versions of Go. They're using older versions of the standard library. So even after you fix it, there are going to be people who are going to be running into this problem. Filing an issue is a good way to rank in Google really highly. Again, people don't read, they scan. So people search on Google a ton. When I was doing documentation at Twilio, we found that like half of the people were coming to our docs straight from Google. Like they weren't clicking around the links. They were just going to Google and then straight to our docs from there. Same is probably true of Go. Google searches are a really underrated way for how people are discovering things and finding answers to their questions. So file an issue that also communicates to everyone else what you're working on, and it communicates the progress of what's going on. So it's open, you type it up, I'm working on this, and then it gets closed when you submit the change. So here's the issue, again, following the template of here's what I was doing, here's what I expected to see, here's what I actually saw. I expected to see documentation that was newer than 2009, and I did not see that. And then I got this really nice response from Adam Langley, who's kind of a very famous cryptographer, who explained how script worked. That was really nice of him. And then I updated the documentation to say, well, here's what these are in 2017. And if you're reading this in 2020, here's how you can figure out what you should set these parameters to, right? So added this and added an example while I was at it, right? So you can do this, right? If you read documentation that's out of date, file an issue, and then see if you can work on a fix. So the golang.org/x repos, there's a lot of code in there. You might have used some of it. There's packages like xnet and xsync. that are somewhat common. They're more experimental. The APIs are a little more flexible. The contribution process is a little less rigorous. The change management process is a little less rigorous than the standard library or the compiler. So they're a great place to get started, and a great place to get a great place to make code contributions. In particular, all of the code that runs the Go build environment, the Go build world, lives in the X repos. For example, GopherBot, the code for GopherBot lives in the X build repository. And there are a lot of things that we could do with GopherBot, or automated changes we can make to repositories that we're not right now. And this would be a possibility. This would be a possible place where you can make a change. This is the Tribot page. So what happens is when you submit a change, we run it on all of these different environments, right? We run it on Macs, on Linux, on Windows 10, on Windows 7, on Windows, mobile, with the race detector on, with the race detector off. And so we run it in all of these different environments just to make sure that they're all happy with the change. And so this is the status page where we learn whether or not that test passed or failed, or that change passed or failed on all of these different environments. This page is not very good. There are a lot of improvements that we could make, and it's really just about not having the time to invest in this, right? Or maybe not having the skill, the sort of user experience or design expertise to make this page better, right? So I found the sort of possible improvements we could make in like 5 minutes of kind of thinking about this page. But you could help with this, right? And this would be really helpful to the Go team. For example, like you could see failing builds at the top, right? Because that's what you're interested in most of the time. The information on the page could be presented in a more useful way, right? That would be a really useful contribution that you could make. And then once you make that contribution, you feel a little ownership over this tool and feel emboldened to make further, bigger contributions and learn how the toolchain works and introduce yourself to the team. So it's super valuable in that way. So how do you get started contributing? If we were street racing in Tokyo, it would make sense to make a flashy entrance and announce your presence and be really visible and come in with a bang. But we're not street racing in Tokyo. We're incrementally making a programming language better. And as such, it's a really good idea to lower your expectations for your first contribution. Again, this doesn't need to be like the biggest, coolest thing that shows everyone that you're brilliant. It should be really small because there's a lot of other stuff going on besides the actual code change when you first get started contributing to Go. So this is one of the first changes I ever made. It's literally one character. And you might be thinking, well, it's one character, that's trivial, and I don't want to bug Brad Fitzpatrick because he's busy. But this kind of thing is really, really important. There's no change that's too small because there's a lot of other stuff that's going on here, right? Like, I'm demonstrating that I can write a commit message that follows the guidelines, right? And if feedback is requested, I can update the change with that. I can write a commit message that makes sense. It demonstrates I'm familiar with the build tools, right? And it's helping the team kind of build trust in my ability to make a change. And it's helpful, right? Like, this is saving people a redirect, so that's useful. And we're all good security people, and we should be encouraging the use of HTTPS where we can. This was the second commit I had. It was 2 months after the first one. Again, that's super common, to make a change and then not make more changes for a long time. I was reading through the runtime and found a spelling mistake and fixed it. Third commit, 2 months after the second one, same vein. And then soon after this, I started reading through the commit logs as they came in when new commits got added, which is a super useful way to get ideas for new changes to make or submit patches based on the patch that just came in if there's something that could be improved about it. But yeah, these are all super small. Like, this is pretty typical, so don't think you need to be a hotshot or brilliant. This is all like the smallest possible change that you can make, and it's all super important. Small commits are really common also. So more than half of my commits are under 20 lines of code, added or removed. And Brad Fitzpatrick is, for example, I was looking this up last night, he's one of the most prolific contributors to the Go project. But even like almost half of his commits are under 20 lines. So yeah, so I mean, just because a change is small, like it doesn't mean it's not important, and it doesn't mean that it's embarrassing or that you're embarrassing someone by submitting it. It's a really good way to build trust, for the team to build trust in you and for you to understand how the contribution process works, and start feeling a little bit of ownership over the code base. This is from the Node project, but this is a really telling quote, I think, from Mike Howell Rogers, who's one of the leads of the project. He said, "I've seen someone barely dip their toe into adjusting the Node.js website. A year later, they had helped onboard more committers, and now one of the top-level decision makers in the core project." This is really, really common, right? And this is why small commits are so important, is because they open the door to ownership in a larger role in the code base, right? So don't think just because you're fixing typos that like you're going to be pigeonholed as the typo fixer forever. It's the gateway to making larger changes. You can practice committing. So we have this. You can follow this URL. We have a Scratch repository set up. So even if you don't have an idea of where you want to contribute, you can go to that URL and practice, right? And you can like practice typing out a good commit message. We give you a directory, and you can put whatever you want in there. It's fine. It doesn't matter. And we'll review it like it's an actual change. So we'll check that it has consistent variable naming, and we'll check that it conforms to the style guide and everything else. We'll check that it has a license header, for example. So every file that gets committed needs to have a license header that says copyright the Go authors. And so we'll check that as part of the process. I mean, you can't screw anything up here, and you can take as much time as you want. So I highly recommend you go through this, even if you're not interested in contributing, just to learn how the process works. Because it is a little unusual. It's different than most companies, just in terms of the rules about what a commit message should look like and what files should look like and everything else. So this is a great way to practice. I highly recommend it. The theory of contributing, so this is kind of how a contribution works. You get an idea, you investigate it, you get stuck, and then one of two things can happen. You can figure out how to persist and get through it, or give up. And I've given up plenty of times. It's not bad. Each of these are valid options. But we don't want you to give up because of a reason where you didn't need to give up. So if you are getting stuck, please get help. There are lots of places where we would expect you to get stuck. It would be anticipated. There's places where the documentation is not good enough. There might be things that you don't know in the Rumsfeldian sense. Resources for help, there's the Golang dev mailing list. Super friendly list. Again, you can follow the same template of using an error report for how you got stuck. So here's what I was trying to do, and I don't understand how this works. Can someone help me out? There are 2 channels in Slack that are super helpful for contributing. You can just post an issue on the Golang project. Here's what I was trying to do. Here's where I got stuck. Since it's probably a process problem and a process improvement, it's certainly valid to report as an issue. It's OK to not know, and it's OK to make mistakes. Like, there are plenty of times where I've looked into something and been like, oh, I could improve this. And then it turns out that's not right, or it was totally wrong, and I wasted a bunch of time. So that's fine. That's totally happens. It's totally normal. As long as you're enthusiastic and open to feedback, that will be very well received. It's on our team too. It's a process issue if people are getting stuck. So if you have a problem, talk to me, talk to Steve Francia, talk to Andrew Bonventry, post an issue, post on the mailing list, and we'll see what we can do to improve the process. So far in this talk, we've premised the entire thing on yes, you should contribute, but I think there is a valid question to ask of whether you should contribute, depending on your circumstances. Some people do get paid to contribute, and that's really great. That's ideal. this is the situation you want to be in. But other cases, people are contributing for free, and they're delivering a lot of benefit to the project and to, in many cases, multi-billion-dollar companies, but not internalizing any of the benefits from that. And that's not a great situation to be in. We don't want you to be in a situation where you're delivering a lot of benefit and you're not capturing any of that, right? Which is a fancy way of saying that you should get paid, directly or indirectly. And it can be really easy to not notice this, right? Like you might be talking to people that are getting paid and not realize it, right? And it's easy to get sucked in because it feels really important and helpful and valuable to the community. It might be worth it. It's worth it for me, right? I don't get paid, but this is my business, so it's worth it in other ways. I can go to clients and explain. Here's my understanding of this is better because I've contributed, right? And I can talk to these people. So it might be worth it, but you have to evaluate that. My last comment is to organize, work with your coworkers to make the world better. And you might be saying, well, my salary is good and I have a micro kitchen, and I have a commute to work, and why do I need to organize, right? Well, this is one of the benefits, right, is your employer might not be as invested as you are in your career growth, right, which can come from open source, right? Like, look, I'm speaking on a stage, right? Like, your employer might not be as invested in that as you are. Your employer might not be as invested in the success of the language or the success of the library that you're using. They might not be as willing to financially contribute, right? And this is a place where you and your coworkers can get together and try to demand a world that better fits and helps make the world better and helps make sure that your career is getting further and that our languages are healthy and our projects are healthy and stable. So thanks very much. That's all I've got today. I'll be available for talks at the end of this. So thanks for listening.